This video is part 3 in the Why Are Humans Aging, and it's about mitochondrial dysfunction. Mitochondria are intercellular organelles that provide energy to the cell. Hundreds of mitochondria, which are highly active components, are found in every cell. They replicate and fuse, not every, pardon me, it's erythrocytes and some cells in eyes don't have mitochondria. Okay, mitochondria replicate and fuse with other mitochondria, exchange molecular machinery, and can even transfer between cells. The majority of their DNA has migrated into the cell nucleus, but a few genes remain to form circular mitochondrial DNA. Age-related mitochondrial dysfunction and an increase in reactive oxygen species production, and this is also will cause cellular damage and accelerated aging. Cellular damage including cellular damage of membranes of the mitochondria. Here we see schematical presentation of the living cell with mitochondria. Here, 1, 2, 3 mitochondria, and they produce very efficiently produce energy by oxidative phosphorylation, so-called. Okay, reacting oxygen species are chemically active oxygen-containing substances produced in excess by dysfunctional mitochondria in comparison to the body's ability to neutralize them. This is referred as oxidative stress. Peroxide, superoxide, hydroxyl radical, singlet oxygen, and alpha oxygen are all examples of reacting oxygen species. In reactive oxygen species in excess, they damage polyunsaturated fatty acids, DNA, RNA, and proteins, all of which contribute to aging of this oxidation of these components, contribute to aging of the body. Mitochondrial DNA is especially vulnerable to oxidation, which is a major cause of aging because reactive oxygen species produced inside mitochondria. So this is why DNA is especially vulnerable to damage. Antioxidants, particularly glutathione, are important in lowering reactive oxygen species levels. Glutathione production, on the other hand, declines with age, resulting in accelerated aging. Here is schematically presented healthy mitochondria, which is producing energy by oxidative phosphorylation of fatty acids, glucose, and amino acids, and some amino acids. And here the damaged mitochondria, which is producing increased level of reacting oxygen species. It can have damaged membranes, so it is not working properly, and we have deficit of energy in the cells. So it is known that mitochondria convert saturated fatty acids to ATP, to energy molecules, more easily than glucose and unsaturated fatty acids. Oxidation of glucose in mitochondria occurs faster, but with an excessive release of the so-called reactive oxygen species that are chemically active substances, as I said. Therefore, avoiding carbohydrates and following ketogenic or carnivore diet with animal saturated fats is the best choice to slow down aging. Intermittent fasting and training during such fasting would allow us to cycle a process mitophagy to remove defective in all mitochondria, and in the process of so-called myoneogenesis, replace them with a new mitochondria. Here schematically we see production of energy in cytoplasm by conversion, but fermentation of glucose to pyruvic acid, and here we have production of energy in Krebs cycles and oxidative phosphorylation. This is in the electron transfer scheme and this transfer system, and much more energy molecules is produced such way, so it is much more efficient. But here we have production of CO2 and water, and here we're saving atoms of carbon, so it is actually good for hyperactive cells, which are cancer cells, and also cells, zombie cells, and cells infected by viruses. Here again we have this Warburg effect. Warburg effect, it is that healthy cells produce energy both. They can produce in anaerobic conditions, they can produce by fermentation of glucose to pyruvates and then to lactate. To lactate, it is ions of lactic acid, And then by oxidative phosphorylation it is much better. It is producing 36 molecules of ATP, so it's much better way, and not so many reactive oxygen species produced in this process. But in tumor cells, even in presence of oxygen, what is happening? Mostly the cells are using this anaerobic glycolysis to produce pardon, to produce lactic acid ions, lactates, but a small part of the pyruvic acid ions go to mitochondria, and they produce some energy, but not much. In total, it is only two ATP molecules here, two ATP molecules here, but it is producing, along with ATP, it is producing a lot of reactive oxygen species. Mitochondria can move, split in half, and fuse with other mitochondria. This fusion and fission cycle allows defective mitochondrial DNA copies to be eliminated. Intense aerobic exercise, I would insist, aerobic exercise increases the number of mitochondria in cells. Soundness and exposure to cold temperature also aid in the formation of new mitochondria in the process of this new mitochondria genesis. And increasing the number of mitochondria reduces stress on each mitochondrion and reduces reactive oxygen species level in the cells. However, excessive anaerobic training like weightlifting, very intense such exercises, can result in the accumulation of reactive oxygen species and damage of cell membranes, and even to apoptosis of the muscle cells, especially muscle cells. In the elderly, mitochondrial dysfunction develops mostly because of chronic hypoxia, the absence of oxygen to use oxidative phosphorylation, and especially it is in muscle cells, resulting in increased reactive oxygen species production and in an ability to convert fatty acids to energy, because fatty acids can be converted to energy only in mitochondria in presence of oxygen. So instead, glucose is used as energy source, and ATP molecules are primarily produced during the glycolysis process in cytoplasm of cells. This aerobic oxidation also happens, but not efficient, with a lot of reactive oxygen species. Meanwhile, liquid fatty acids drops accumulate in cells because fatty acids cannot be used as source of energy. So deficit in energy production is causing the development of sarcopenia. Intense physical activity, intermittent fasting, and low carbohydrate diet, on the other hand, may help to improve mitochondrial function. This is again quite an art to do, because it depends on intensity, depends on duration, depends on the diet, etc. In a mouse study, researchers activated a mutation that resulted in a loss of mitochondrial function, similar to what happens in aging humans. Within 4 weeks, the mice developed gray hair loss, and lethargy, loss of energy. The mice skin started to sag under 4 to 8 weeks, resembling both intrinsic and extrinsic aging, such as that caused by smoking or sun exposure in humans. The mice skin outer layer thickened, the number of skin cells increased, there was inflammation, and the hair follicles were dysfunctional, all of which are symptoms of extrinsic aging in humans also. The researchers, however, were able to stop the mutation and then to reverse the effect, so to make mitochondria again working efficiently, and then all the effects of the aging were reversed. We see here the picture. So initially healthy mice was treated so that they lost functional mitochondria. Not all, but mitochondria became dysfunctional, and we see aging develops in the mice. And then when they reversed, they stopped this mitochondrial dysfunction, then they got amazing rejuvenation. With amazing, all recovered. So rejuvenation is possible, as you see, at least in mice. But we have to reverse this degeneration of mitochondria and make number of mitochondria much larger in the cells. Okay, it is interesting that in NAC mouse rats, the mitochondria in time number of mitochondria is increasing. It's from 5 years old, the number of mitochondria in NAC rats is increasing and gets maximum to age of about 11 years, and then it stays for long, and there is no sign of aging in NAC rats. If NAC rats die, they die from starvation, they die from from dry conditions, no water, and also from injuries and infections. They are not aging. They actually permanently, they can live forever, technically speaking, but they die just because of this accident. Anything can happen. Okay, so this video was done for educational information purposes only. It has pictures. I always give reference to the sources of the pictures. The link to the presentation, PDF file with presentation is in the video description. And in this video, I express my personal opinion. A visitor of my channel is advised to discuss the content of this video with his or her personal physician. Only act upon advice of the professional medical experts, what I never do because I'm doctor of science myself. I never have any good reason to consult with medical experts because I'm never getting sick for almost 30 years. I don't have even a flu. If now I'm coughing, it's a little bit because I have to drink some water. Okay, but I feel quite good, and this technology to increase number of mitochondria, I think works because I have a lot of energy. I have a lot of energy, and it is great feeling. You cannot buy it for any money, I believe. So it works for me quite well. Okay, thank you for your time to watch the video. Please comment, subscribe, like, ask questions, and share information. Have a wonderful day. Ciao, ciao.